Two of the most amazing spacecraft ever launched would never have taken flight if the stars hadn't lined up. The four largest planets in our solar system were the stars in this instance. They were progressively spinning into an array that hadn't happened since Thomas Jefferson's presidency in the early 19th century, about 60 years prior. The unusual planetary set piece first went completely overlooked. Gary Flandreau, a PhD candidate in aeronautics at the California Institute of Technology, was the first to draw attention to it. Within 15 days of one another, Voyager 1 and Voyager 2, which were identical in every way, were launched in the summer of 1977. They have been operating in space for almost 45 years and send data back to Earth every day from the solar system's farthest known planets. They have lasted longer than any other spacecraft in history and have traveled farther. However, NASA has revealed something much more startling. The Voyager is returning to Earth. What does this signify for space exploration, and how is that even possible? You will get to know this and plenty more as we dive into the details of today's show. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. How far have you ever traveled from your home? If you were the Voyager 1, you would have gone billions of miles and be relieved to be back home. Voyager 1 is actually the farthest human-made object in space, having traveled close to 15 billion miles. The spacecraft is the first to ever have left the solar system and entered what is known as interstellar space. Since its launch in 1977, the Voyager 1 has caught the public's attention for many years. But no one could have predicted that almost 50 years later, the mission would still be operating and still be returning data. In August 2012, the spacecraft entered interstellar space about 35 years after it first started its journey. The discovery, however, was not made public until 2013, after researchers had time to examine the information Voyager 1 had returned. Despite being the first to race between Jupiter and Saturn, Voyager 1 was the second of the twin spacecraft to be launched. The pictures that Voyager 1 brought back have been utilized in textbooks and by several media outlets for a generation. The spacecraft also has a unique record called the Golden Record that is intended to send Earthbound sounds into space. The once every 176-year alignment of the outer planets was utilized by the Voyager probes. By making the best use of their limited fuel, spacecraft may slingshot from one planet to the next thanks to this alignment. In addition to sending two probes past Jupiter, Uranus, and Neptune, NASA also intended to send two probes each past Saturn, Pluto, and Jupiter. NASA had to modify its plans because of budgetary restrictions, but the two Voyager spacecraft nevertheless made significant progress. Voyager 1 lingered near the Jupiter and Saturn, while Voyager 2 passed by Jupiter, Saturn, Uranus, and Neptune. Three radioisotope thermoelectric generators, which turned the heat generated by the radioactive decay of plutonium into electricity, powered both spacecraft. A total of 10 scientific instruments, including a magnetometer, numerous spectrometers, a two-camera imaging system, and detectors for high-energy cosmic rays and low-energy charged particles, were installed on both probes. Members of the mission's crew have also used the Voyager's communication systems to investigate planets and moons, bringing the total number of scientific research on each craft to 11. Voyager 1's rocket nearly ran out of fuel at launch, which is an interesting fact. Nonetheless, the probe made it to space safely and sped ahead of its twin after launch, crossing beyond the main asteroid belt between Mars and Jupiter before Voyager 2. A historic journey. Voyager 1's first destination was Jupiter, where it arrived in March 1979. The spacecraft conducted a flyby of the gas giant, coming within 174,000 miles of the planet's surface. During the flyby, Voyager 1 observed Jupiter's turbulent atmosphere, its moons, and its powerful magnetic field. The spacecraft also discovered a new ring around the planet, and its images of the volcanic moon, Io, revolutionized our understanding of the outer solar system. After its encounter with Jupiter, Voyager 1 continued on to Saturn, arriving in November 1980. The spacecraft conducted a series of flybys of the gas giant and its moons, including the first ever close-up images of Saturn's rings. Voyager 1 also discovered new moons around Saturn, including a moon with a methane atmosphere named Titan. This discovery was particularly significant as it raised the possibility of finding life-sustaining conditions on other worlds. Following its successful mission at Saturn, Voyager 1 continued on to Uranus and Neptune, becoming the first spacecraft to visit these outer planets. Voyager 1 flew by Uranus on January 1986, coming within 50,600 miles of the planet's cloud tops. During the flyby, the spacecraft discovered new rings around Uranus and observed its unique magnetic field, which is titled at an angle of 59 degrees relative to the planet's rotation. In August 1989, Voyager 1 flew by Neptune, coming within 3,000 miles of the planet's cloud tops. The spacecraft observed Neptune's Great Dark Spot, a massive storm in the planet's atmosphere, and discover new moons around the planet. Voyager 1's mission to the outer planets was a groundbreaking achievement in human space exploration, providing us with a wealth of scientific knowledge about these distant worlds. After completing its mission to the outer planets, Voyager 1 continued on its journey, crossing the heliopause, the boundary between the region of space dominated by the Sun's magnetic field and the region of interstellar space, in August 2012. Voyager 1 became the first human-made object to enter interstellar space, where it's currently traveling through the vast expanse of space beyond our solar system. During its journey through interstellar space, Voyager 1's instruments have been able to study the properties of the interstellar medium, including cosmic rays and the interstellar plasma. The spacecraft's measurements have provided scientists with valuable insights into the nature of the universe beyond our solar system. The Voyager 1 spacecraft crossed the heliopause, the boundary between region of space dominated by the Sun's magnetic field and the region of interstellar space, on August 25, 2012. This marked a historic moment in human space exploration as Voyager 1 became the first man-made object to enter interstellar space. The crossing was confirmed by analyzing data transmitted by Voyager 1's instruments, which detected a sharp increase in the density of interstellar plasma and a corresponding decrease in the intensity of the solar wind. This indicated that Voyager 1 had left the heliosphere, the bubble of charged particles surrounding the Sun, and had entered the interstellar medium, the space between stars. The successful entry of Voyager 1 into interstellar space provided scientists with valuable insights into the nature of the universe beyond our solar system. A move to conserve energy. Several instruments on the Voyager 1 probe were turned off over time to conserve power and prolong the spacecraft's life. As Voyager 1 moved farther away from the Sun, the amount of sunlight available to power its instruments decreased. In addition, the spacecraft's radioisotope thermoelectric generators (RTGs), which provide electrical power from the natural decay of plutonium-238, also began to produce less power over time. To conserve power, NASA decided to turn off some of its instruments on Voyager 1 that were no longer critical to the mission. For example, the spacecraft's imaging cameras were turned off in 1990 after completing their primary mission to study the outer planets. The infrared spectrometer, which measured the temperature and composition of planetary atmospheres, was also turned off in 1990. The ultraviolet spectrometer, which measured the ultraviolet radiation emitted by the stars and other celestial objects, was turned off in 2000. However, some instruments on Voyager 1 continue to operate, including the cosmic ray instrument, the magnetometer, and the plasma wave instrument. These instruments provide valuable data on the properties of the interstellar medium and the effects of interstellar space on the spacecraft. Despite the gradual shutdown of some of its instruments, Voyager 1 has continued to operate and send back data for over 45 years since its launch, making it one of the longest-lasting and most successful spacecraft missions in history. Communication system. Voyager 1 communicates with Earth using a high-gain antenna, HGA, which is a 12-foot, 3.7 meters dish-shaped antenna that is pointed toward Earth. The spacecraft uses radio waves to communicate with the Deep Space Network, DSN, a network of 3 large antennas located in California, Spain, and Australia. The DSN is operated by NASA's Jet Propulsion Laboratory, JPL, and is used to communicate with deep space missions such as Voyager 1. Voyager 1's transmitter sends signals to the DSN, which are then processed by computers and sent to mission control. The spacecraft's transmitter has a power output of about 22 watts, which is less than the power of a refrigerator light bulb. However, the signals sent by Voyager 1 are very weak by the time they reach Earth, as they have traveled billions of miles through space. To detect these weak signals, the DSN uses large antennas and sophisticated receivers that can pick up extremely faint signals. Due to the vast distance between Voyager 1 and Earth, it takes over 20 hours for a signal sent from Earth to reach the spacecraft, and another 20 hours for the spacecraft's response to reach Earth. This means that communication with Voyager 1 is a slow and complex process that requires precise timing and coordination between the DSN and mission control. Getting closer to Earth? Really? Advancing our knowledge of the solar system or the universe and eventually our place within it. The distance between the Earth and Voyager 1 actually decreases for a few months every year. It appears that the spacecraft is heading back to the planet. Why is that so? The orbit of Earth moves away from the spacecraft for a few months each year and then moves back towards it. The Earth orbits the Sun more quickly than any other spacecraft. For example, when Earth is on one side of the Sun and Voyager 1 is on the other side, the distance between the two is at its greatest. However, when the planets are on the same side of the Sun, the distance between them is at its minimum. This alignment occurs roughly once every 175 years and is known as the Grand Alignment. In addition, NASA also uses a technique called gravity assist to help Voyager 1 and other spacecraft move faster and change their direction in space. This involves flying the spacecraft close to a planet such as Jupiter or Saturn, and using the planet's gravity to change the spacecraft's velocity and trajectory. 0.30 kilometers per second, or 67,000 miles per hour, is the speed at which the Earth orbits the Sun. 38,210 miles per hour or 17 kilometers per second is the speed of Voyager 1. 15 kilometers per second or 35,000 miles per hour is the speed of Voyager 2. Earth orbits the Sun over a period of the year during which it accelerates towards the spacecraft more quickly than it can accelerate away, bringing its distances from Earth closer. We are the ones who has changed, albeit only momentarily since they never modify our outward movement. Voyager 1 will travel so far above the galaxy's main disk that it will only see stars with half the density that we do. The odds of the golden record on Voyager 1 being destroyed are very low. The golden record is a time capsule that contains a selection of sounds and images that represent the diversity of life on Earth. It is made of a durable material that can withstand the extreme conditions of space, including radiation, extreme temperatures, and micro-meteoroid impacts. The record is protected by a protective aluminum case, which is designed to help protect it from the hazards of space. The case is also sealed with a vacuum seal to prevent contamination from the outside environment. Even though the odds of the golden record being destroyed are low, it is still possible that it could be damaged or destroyed by a collision with a large piece of space debris or a micrometeoroid. However, the likelihood of such an event occurring is very small. In addition to the physical protection of the record, the Voyager 1 spacecraft is also moving away from the Sun and is unlikely to encounter any large objects in its path. The spacecraft is currently traveling through interstellar space and is expected to continue on its trajectory for billions of years without encountering any significant hazards. Overall, while there is always some risk that the golden record could be damaged or destroyed, the protective measures that were taken and the remote location of the spacecraft make this a very unlikely scenario. In conclusion, Voyager 1 has been a remarkable achievement in space exploration, traveling farther than any other man-made object in history. After 45 years of continuous operation, the spacecraft is still functioning and sending data back to Earth. Voyager 1 has provided scientists with a wealth of information about our solar system and the vast expanse of interstellar space beyond. Even as it continues its journey into the unknown, Voyager 1 remains a testament to human ingenuity and the spirit of exploration. Its legacy will continue to inspire generations to come as we continue to explore the mysteries of the universe. What are your thoughts on this glorious end that is imminent for Voyager probes? Do let us know in the comments section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching, and we hope to see you at the next one.